Laptop buddy.
Yeah. I was like, what are you talking about? My stuff hasn't come yet. He's like, what stuff? I was like, walking stamp. He's like, this bus never passes through the walking stamp. I was like, what? And it was 11:30, so it was the last bus.
Oh no!
I was like, what am I supposed to do? He's like, take a taxi or find another bus. I was like,
Just get off my bus.
Yeah. I was like, thank you, that's so much help. And then I pull out my phone,
Yeah.
which, remember my S7 Edge broke?
Yeah.
I got a new phone, this one, which is not waterproof.
Yeah.
This was like the next week.
There you are, we're waiting for everybody. Did you? Because I'm getting lots of chocolate from people today for some reason. Just add it into the bag.
Is it the people that were late? Do you have any dark chocolate?
Sorry, I said I'm getting a lot of chocolate. This is my chocolate.
No, I wasn't going to give
You
you
probably don't like dark chocolate.
I like all chocolate. I don't discriminate. I'm not racist like that. I like dark and white chocolate.
Oh, I am. But the chocolate.
Keep that away for one. So where's everybody?
I have no clue. I went to Spark, got my lunch.
Is this your last class of the day?
We have 3 classes ready. Yeah, like at St. Patrick's, so we can have fun, maybe.
We'll see. We'll see.
Lee is in 3 and IB appointment. I know that much.
Fair enough. Wong, David.
I've seen them.
Sorry, David is Lee. Sorry. Wong.
I've seen them, but like.
Maybe they're late because they're getting me gifts.
Maybe.
I could always hope.
Dream big.
Dream, yeah. Yeah.
So, is today the deadline for the applications
Which ones?
for Irish universities?
No. Is it for the UK ones? I thought there was some
We
deadline
still-
this week.
We still didn't get our UCAS.
Do you know what it is actually? Maybe I'm thinking of the September students or January. You've made your applications? Or you're going to the UK, so you need to do UCAS.
Well,
You're doing both.
Ireland.
Okay, yeah. You're Ireland
Ireland.
and Faisal?
You in Ireland, yeah.
Yeah. So only you need to do UCAS here.
I did, like, he was meant to
anything about deadline?
send us, like, our accounts recently. Last week, he was like, he showed us a presentation and then we're gonna send you your accounts in today.
Oh, you said that too fast. He showed you a presentation and then...
About UCAS
Yeah.
and explaining it
Yeah.
and everything. And he was like, he's gonna send us our accounts in a couple of days.
Yeah.
Like, it was like 2 or 3 days.
Yeah.
And he still hasn't sent
And do you know what your mistake was?
What?
You believed something you heard.
In the IFC.
No, just in life. Yeah. Yeah. It's, I don't know, maybe it's a cultural thing.
Yeah, maybe.
Finally, we have some more. Who have we got?
Yo. Yo.
Sup, bro? Yes, come on. Waiting for everybody.
Hey, Kenny.
My candy. You want to sit there in front of the projector
Yeah.
and get blind. Fine. If you want to be blind, that's no problem with me.
Nothing.
The deadline for the application
Yeah.
is it today?
Which applications? No, what deadline?
University applications.
Which one?
She sent us an email yesterday and she said...
An email yesterday?
Yes.
From
she,
this
she
email?
also said, yeah. She
No.
also said that
Hmm.
No, she's...
Because I asked so many people and no one knows about this. Everyone's like, no, we have 2 more weeks for it.
The only email she sent was about the individual tutorial, that's it.
No, she sent us an email
Okay.
about
As you
Calm
would.
down.
application.
I'm very calm.
What did you ask?
Look how calm I am.
Like about, did you ask
Did
about-
you-
I know you are the
No,
best.
I have the email.
I don't
Yeah.
even know.
You
I'm
want to read
okay.
Is it from email?
Yes.
Yesterday?
Yes.
I don't have anything from her except the individual tutorial.
And I went to Sylvia, she knew about
Are you going to help me?
And I gave her my
If I can.
this
Good,
morning
good.
before class. And Omar was there.
Guys, why are we all coming in late?
Because we played piano.
You played what?
Piano. Ping pong.
Full billiard.
Yeah.
Yeah, I didn't
Okay.
get this.
It's so cool.
Yeah, I'm sure it is. But I'd like to start physics now, please. Okay, now. Come on home.
Fawn, did you see the bag?
She did.
Yeah.
He got it for you.
Me?
Yeah.
Don't listen to his lies. He's king of lies. Don't listen to him.
I thought it's so true.
No, no.
Yes, it is.
No, no, no. You said you were on a diet. Look at you. An apple. Very good, very good.
Said
Is
if
this
you
your
do
lunch?
the homework, I'll give it to her.
Yeah.
Very good. Good job.
Before that I eat hamburger.
Hamburger. Oh my goodness. With chips.
Yeah.
Yeah. I whatever diet she's on, I like it. She got hamburger, chips,
Apples,
apples.
healthy.
Yep. It's a balanced diet.
And grapes.
Oh, and grapes. Oh, well then, I suppose the chips are okay. All right, we'll start now. Working power. So we haven't got too much left in electricity because if you look at our topics, we have 11 topics to do: working power, EMF and internal resistance, and potential divider. We have 2 hours now, so we'll get 2 topics done, leaving us with homework and 1 topic to do after the weekend, and then we can start waves, and waves is the shortest one. Waves is only 5, so I would say 2 more weeks and we're finished. Now, how many teaching weeks do we have left? Please say a number bigger than 2. How many teaching weeks left?
I think
And that's
Till
it.
Easter break?
until
Yeah, in other words, how many
Until Easter break, 3 weeks.
2.
No, not the break.
No, I want to know basically how many teaching weeks. How many more weeks will I see you for?
Still one.
Until the exams.
Till the exams. I only care about the exams.
We have 2. We have not like 3.
Yeah, this is the third. This is the first and 2 more.
2 weeks. Yeah, 2 more. So we finish exactly like before the break.
It would have been nice to finish a bit sooner. Although I might be able to arrange maybe a couple of revision classes after the teaching finish, but before you have your exam. We'll see. It's the problem is the January program which you're on is the tight program. Everything is fast and go. Okay, working power is not so difficult. Let's have a look at that now. Okay. So we care about electricity because it can do work, and we know this from day-to-day life. You know, the electricity in our home, we can use it for computer, TV, cooker, microwave. It's just so important for modern life. So we care about electricity because of its ability to do work. Some of these things may be new to you. For example, this.
What is the first one?
Exactly, yes. This one here?
No.
This one?
Yeah.
Ah, yes, this one, a toaster.
What's that?
What is a toaster for making toast?
Yeah, you
What is
put toast in it.
What is toast? Cooked bread.
Bread? Oh,
bread
the bread.
that is like this.
Where?
Square bread.
Ah.
And microwave.
And then
Yeah.
You have these?
But it's different in my home style.
How so?
Yeah,
Bigger?
the one that opens like a.
that's not a toaster.
Yeah.
But
What is it? The grill. Yeah, grill. Yeah.
we call it a waffle iron.
If it has the lines, yes. If it doesn't, then no.
It's completely smooth. It doesn't even have
No,
a...
it can't be. I don't think
No,
so.
they're all.
Yeah, okay. Well, anyways, toaster. Don't worry, I won't ask you this in the exam. Right. So electricity is a form of energy. Remember that 1 volt means 1 coulomb can do 1 joule of work. So if we think about that, 1 volt means 1 coulomb can do 1 joule of work. So for example, 2 volts would mean 1 coulomb could do 2 joules of work. So you get it? So like 3 volts could mean 1 coulomb could do 3 joules of work. You get the 3 volts. Well, I'm just repeating myself. So if you think about it, it's just the charge multiplied by the voltage. So for example, if you had 3 volts but 2 coulombs, each coulomb can do 3 joules. So in total here you would have 6 joules. So in other words, the simple formula is the work is equal to the charge multiplied by the voltage. This is our first formula. You got that? Yes? Yep. Continue. But we can rearrange these formulas. So, for example, you remember we have our VIOR triangle, and we also have the formula, I think I gave this to you, Q equals IT. So here what I could do is replace the Q with IT. Can you see that? The Q is replaced with IT. Then I could divide by T. So what is work divided by time? Power. So I get this formula. Power equals IV. Power equals IV. Yeah? Yeah?
Work equals to IVT.
Yeah. Work over time equals IV.
Okay.
Work over time is power. Yes? Yeah? Okay. Continuing now. And we could, if we, so this is like one way to write power, but another way, if we think about our VIOR triangle, we could replace the V. What could we replace V with? V equals IOR. So if you replace the V with IOR, you can get this formula for power, I squared OR. That's like a second formula for power. And another thing you could do, you could replace the I here. What does I equal? V over OR. So if you replace the I with V over OR, you can get this formula. Power is V squared over OR. It's another formula. Yeah. So we have 4 formulas here of interest. But I never remember these. I just remember this one together with the usual triangle. But these are in the formula book. So I want to just you to see them. Okay, continue. Yes? Right. When a current is running through a resistor, initially there's been no charge passed through it until at some point there is a charge Q. All the time the voltage is staying constant. Well, let me draw the graph here. So, which way do I want to? I want to put something on the bottom. Yeah, I think I'll draw the graph like this. So here is Q, and then here is V. Yeah. And here is my resistor, and then here is my current. So at the very beginning, when I turn the switch on, no current has passed through the resistor yet. So for example, let's imagine it's 1 amp. Do you remember what 1 amp is? What's another way of writing amp? It's 1 something per something. Anyone? Per second. So at the beginning, there's no charge. Then after 1 second, how much charge traveled through the resistor? 1. So 1 coulomb. Then after 2 seconds, another coulomb travels through. In total, how much passed by the resistor? 2. So as the total, this is like total, increases, you notice that the voltage stays the same. The voltage doesn't change here. Now this graph doesn't seem very interesting, but it'll become important in a moment. What is the area here? The area is Q times V. What's Q times? Work. So the area on this graph is work. So this graph isn't interesting. The next graph I want you to draw is interesting. So rather than a resistor, let's imagine you had something else like a capacitor. And here we have Q again, and here we have V. Yeah? Now do you remember the formula for Q for a capacitor? No? I'll give you a clue. Remember, it starts with Q0? No, we've forgotten.
Did we take it?
We did. Yeah. This is the formula for Q. Yes? And what was the formula for V? Yes? So Q over V equals Q0 E minus T over tau over V0 E minus T over tau. What happens here? We get some cancelling, don't we? Yeah, so Q over V equals Q0 over V0. If I rearrange this, I can say V equals V0 over Q0 times Q. In other words, the V is equal to a constant times the Q. What shaped graph is that? Remember, this is like the Y, and this is like the X. So you're saying Y equals a constant times X. What type of graph do you get? Linear. Linear. Passing through the origin. What's the formula for the area here? Aha, QV. Yes? So, you have the formula for the work of a capacitor. Previously, we had the formula work equals QV for a resistor. It's nearly the same as for a capacitor. The only difference in the formula is the half. So we have now the energy stored in a capacitor, its work it can do, is a half QV. But do you remember the formula for Q in a capacitor? Q equals... No, not that one.
Q and what?
Do you remember the formula that had C? Well, remember the formula for capacitance? C equals... No? Q over V?
Okay. Yeah.
So Q equals CV. So if you put that in here, you can get work equals a half C voltage squared. So this is how much work a capacitor can do. In other words, it's like saying how much energy is stored in the capacitor. So this is an important formula that we just proved. If you can write this down, you don't need the proof for the exam, but I would like you to write the proof down because you all seemed a little bit rusty on these formulas. So I think it'd be good for you to write this down.
Did you put like numbers and stuff?
Yeah, the steps. Yeah. So let's see. First, I started here. You know what? I'll just put little numbers. So this was 1 and 1, and I put them together to make 2.
This is for a capacitor or working with a capacitor?
Yeah. This becomes 3. This becomes 4. Then I looked at the graph up here, which is 5. and then I was able to make this formula 6. Then I could use this here in the formula, and then finally arrive here. So we're just missing Lee. Lee talks too much in class, so it's good that he's not here. We can get a lot done. Tell him it's so nice not having him here. Tell him we don't miss him, and he can go to GNIB more often.
Tell him about
Talk.
Just start talking, Mr. Cole.
Oh, hey Lee, we so totally miss you, and we hope you're okay, and have a happy St. Patrick's Day.
That's really what it said.
Yeah.
0 to 100 really quick.
Sure, yeah.
Question.
Yeah.
Not really.
Well, I'm waiting for them to write it down, so go ahead.
Do you have any idea where can I get my camera checked? Because it's not working properly.
What type of camera?
Mirrorless.
Fancy camera, huh? No, I think the best thing you could do, if I remember, although it might have been gone, I could have sworn there was a camera shop somewhere on O'Connell Street where they have fancy cameras. So these would be, you could go in and ask, do they have the contact information of someone who repairs cameras? Because I just remember this shop because the only thing they sell is cameras and all different types of cameras. So I'm sure they've had to get cameras repaired before, and customers needed to get them repaired. So, and in fact, maybe they even offer a repair service. I can't remember their name. I think they're on O'Connell Street because I just remember walking O'Connell Street. A small little camera shop. You could Google, camera shop O'Connell Street to make sure they're still there.
I've seen one over there, but like not next to the square.
Yeah.
Opposite to the river.
Yeah, I don't remember exactly where. But this would be your best bet.
Because I looked online for, it's a Samsung. I looked online for the Samsung Service Center, and there is one like on the borders of Dublin, so I can't reach it by bus.
There's one in Dundrum. In the
That's,
mall.
that's the shop.
Oh.
There's a Samsung service center. What's it called, sorry?
Well, you can get
Yeah.
it there.
It's a service center for, it's a authorized service center. It's not the service.
Oh, I see. So they have permission to say that they can work on these electronics. And where are they? The one that's too far for you.
Yeah, Dublin and
Kildare.
yes,
The border.
yeah.
What town though? Because although there might not be a bus, there could be a train.
How much should I have to pay for the train?
You'll get a student price. So if you'll only be travelling a short distance, because you'll be travelling at most one stop on the train, so it could be like €5.
No. 10.
One stop?
10.
No.
I go to from
From
Dublin to Cork.
Dublin to Cork. Well, I suppose that is one stop. True. But I was thinking one short stop.
But it's 32.
I know.
Okay.
Let me rephrase that, Faisal. You will only be travelling about 5 kilometres, so about €5.
Okay. Around. We need to make it small.
750?
Yeah, 750.
750, Faisal. This is our decision. Right, did you write this down now?
Yeah. Well, I don't
Yeah.
think they will, because like if you need to change a part on the camera, they won't change it.
Yeah, because I got it from UAE, not from here, so it's different parts.
Oh, really?
Yeah, in Europe it's different. Even for phones, Android can fix this phone here because it's from that region of the world.
I see.
They have different
I
points.
see. There's probably it's probably surveillance devices in the phone, is it? Like it's some kind of surveillance
The
chip,
warranty
is it?
says, the
Yeah.
warranty says international warranty. I go to them and they say, oh,
What's
well,
the
limited.
euro?
Oh, it's international warranty, but it's only valid in countries like Dubai
And Dubai.
and
And Dubai.
Yeah.
Countries like Dubai.
Sorry, no. Yeah. Sorry, yeah. It's an international warranty that's only valid in the Middle East.
Yeah.
Yes.
It will be in Asia.
Yeah. In Asia, yes. Yeah.
It's made in Vietnam.
Oh, so that's why it's broken. All right. You got this now? Yes. Question.
Why did you, like, how did you get the half QV from the graph?
Area of a triangle.
Area of triangle, yeah.
So, like, is it, so it's not the gradient? It's,
No, it's area.
Yeah.
Yeah. Okay.
Yes.
So after all that, we get these two formulas, this one, and we can write it like this. Did you write those down?
Yes.
Yep. Okay. Right, here's an example. I'll do it. If you can write this down, please.
Greenwood Business Park.
Let's see. The address.
It's the bus.
Zoom out.
It will take you 1 hour from here.
Ah, yeah, there'll be a bus there.
60.
Yeah, there's definitely a Dublin bus going there, for sure. For sure. There-
Like my homestay.
If you look at the map, Dublin bus goes as far as Blessington. Do you see Blessington on the map there?
Yes. There. Okay, good.
What is the resistor or resistance?
Yeah,
Oh,
resistance.
there's one bus.
Me no speak
One
English
bus is
good.
8 million.
Do you use Google Maps?
Bro, 62 stops to get to this place.
Yeah, but it's not going to stop at every stop. It's only going to stop if you ring the bell at every stop. So just don't do that.
Yeah, I'll make sure I'll tell everyone not to.
Yes, exactly. You say, please, I need to get my camera fixed. If we can all just let me get there quickly. All right.
emailed them.
On the bus, what would happen if you?
Processor not go down.
Yeah.
Well, if it happens once, the driver will just think it's a mistake. But if it keeps happening, he'll get angry. Yes.
There's probably a fine for it.
No, there's no fine. You'll just have the bus driver shouting at you. Oh well, no. Have you ever met an angry bus driver? No, you don't want to. Trust me. Don't want to. All right. We have a 10 kilowatt oven with 220 volts. So let's just write that information down. The power is 10,000 watts. And the voltage is 220 volts. Question 1, what's the current? So what formula could I use here to get the current?
Q equals W over V.
I equals P over V, which is
Oh,
10,000 over 220. What's that, please?
45.
What is it?
45.
Thank you. B,
What's this decimal code? When it
recurrent. Yeah. What is the resistance of the oven? Okay. Well, I can just go with my VI-OR triangle. So what does OR equal?
V over I.
V over I. So, Wong, what's this, please? Or, actually, you said you're going to help me. What's this?
4.84.
C. What is the charge in 1 hour? So, what formula gives me the charge for an hour of current?
I over T.
Q equals IT,
I.
which will be 45.5 times 3,600, which equals
16. 164 kilo charge.
Coulomb. D? How much work? Right, what's the formula for work? We have a couple.
QV.
QV we can go with, yeah. Which will be 164,000 times 220.
36 million and 100,000.
Megajoules. But there is a second way to do this. Or we could have said, power equals, oh yeah, the other one, sorry. Work equals VIT, which would be 220, 45.5, 3,600. Do you get the same answer? I'm sure you do.
No.
What you get?
Oh, 220. Looks like 70.
Close enough.
Yeah.
Or there's another way to do it. The other way to do it is what? What force would the oven be exerting exactly? Power equals work over time. So work equals power multiplied by time. What was the power of the oven? 10,000. 10,000. I don't think this 0.1 should be here. I'm going to round it down to, I'm going to round it to 36. Because here I can see the exact answer quite clearly. 10,000 times 3,600, which is 36 megajoules. Sorry, 3.6? Was it 3 point?
36.
So these are 36, yes. Yes.
P equals, okay.
What's wrong, Omar? Oh. Continue. So, for the last one, you had 3 ways to do it. Yeah, continue. Okay. Next. Right. If you can write the info down, we'll do this one. Hand me my brown bag, please. To your right. Brown bag.
Drop it on your way.
Come on. You said you'll help me if you sit here. You can do it. Thank you. And Faisal, you're always helpful. If you can plug that in behind you there.
So to find the power,
Wait, one at a time.
What's that?
He was speaking first.
Milli.
You were saying?
to find the work of the capacitor, it's a different formula.
Yeah, it is. Yeah. It's a half QV or a half CV squared.
So the other one wouldn't work.
No, it wouldn't. Right, let's have a look here. What's the charge? Right, so let's write down the info here. You know the voltage is 120 and the capacitance is 120. Oh, sorry, 100 millifarad. And what do I want first? Yeah, so what formula is that? Q equals CV, which is 0.1 times 120, which is 12 coulombs. B. What is the energy stored? Right, what's that formula? We had it today. A half CV squared or a half QV. Which one could we use here?
Both.
We could use both. Let's make sure we get the same answer. So this one is a half times 0.1 times 120 squared, or this one's a half times 12 times 120. So here you get 720, and here you get 720. So you have two ways to do this one.
Would there be a question where we are forced to?
You have to, yeah.
If they don't give you Q or they don't give you C.
Well, no, they didn't give us Q. They gave us C and B. Yeah, exactly. No, I don't believe. I can't really imagine a situation where.
If they just say find work from the beginning without asking you to find the charge.
Yeah, but you still could find the charge. I can't really imagine a situation.
I guess it depends on the information they give you and the shortest way to...
Yeah, the quickest way to the answer. Yeah. Okay, C. The capacitor is allowed to discharge through a 100 ohm resistor. How long will the discharging take? Do you remember the formula for the discharge time? Oh my goodness, you have a very short memory because we only did it like...
Last Friday.
2 weeks.
Your best
No, not even 2 weeks.
students were absent on that day. That's why.
Juan wasn't in. Nothing.
Can you,
What?
This is
the question?
Okay, what's the formula for C? Come on, wake up.
Q equal RT?
No.
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 Ah,
I'm making up...
no.
You are. That's not a formula.
Q over C. V.
No.
For the
How?
others.
That's it?
RC.
No.
What's the formula? No.
RC?
No.
T equals...
No. 5 time constants.
You need to find the time constant first.
That's not what I wanted. I wanted this. What's the formula? 5 time constants. Now, Yusuf, what's the formula for time constant?
Time constant equals RC.
Thank you, or C. So it's 5 times... Now, do we have the or? We do. It was 100 in the question. And do we have the C? It was 0.1. So that is 50 seconds.
What's the time constant?
What's the time constant? What's the question? I don't understand your question.
Like, that time was
We did this on the lesson on RC. This is coming from the RC lesson, RC circuits. A couple of people were missing that day. You were missing from that.
Me too.
Told you.
Then we get the...
Oh no. This one.
Yeah, no, you were there. We had it in Cav, remember? No.
Then we get the R.
Yeah, so we don't have the...
Says 100.
Yeah.
Oh, the C point, okay.
In the question, that's the last place I thought it would be. Oh man. Right.
You just...
But it's not us to
He
It's not us
doubted himself
to
for a
have
moment.
to be
He doubted himself for a moment.
I understand. Listen up. Grammar time, please. So Fuang wants to know, why is it 5 time constants when the question didn't say to fully discharge?
Because it's not discharging.
Almost. You're right.
Discharging means finishing all the charge.
How long will this charge
Yeah.
take? It means like how long will it take to finish?
Yeah.
Like, just please.
How long will you take to reach home?
Yeah.
So
It's because, Fuang, it's because the take is here and the ing. It means how long to finish this. You know, how long, for example, how long will studying take? Means when will you finish your study? When is it done? Really? Yeah, so you just learned some ing take.
Interesting.
Very interesting. Very interesting. You should write this down, yes.
What's IR?
IR? Could be infrared. Please don't press it, that could be the self-destruct button.
Or no button?
Maybe it's just for appearances. Maybe if you press it enough it will electrocute you. Who knows? So many choices. Okay, can we do the last part? You wrote this grammar down?
Yeah.
Okay. D. When the capacitor is discharging, it is allowing the resistor to do work. Approximately, what's the power of the light? Now, the reason I say approximately is because the light doesn't stay on. What happens to the light? It gets, what's the word?
It gets dimmer.
Dimmer. So as it discharges, it gets dimmer. So the power is roughly equal to the work done. Well, the work divided by the time. No, that's not roughly. Power equals work divided by time. And what's the work of a capacitor?
Half CV squared.
A half CV squared. And how long to discharge? 5 time constant. We know this, don't we? And we know this. And we know this. So it's a half. What's the capacitance, please? What was it?
0.1.
0.1. No, capacitance.
Oh, yeah, sorry.
Oh, yeah.
0.1.
Yeah.
And what was the voltage?
120 squared.
And the time we said was 50?
Yes.
Yeah, so
Do
what?
we have the answer for that?
Yeah, that's I'm saying is 50.
The one above.
Do we?
Yeah.
Oh, what was it? Thank you.
720.
Yeah, that's right.
Okay, well please use a sentence. It would help me. Thank you. You know, verbs. 720 over 50. So that's 14.4?
Yes.
Question.
Now wait, just one sec. That's not, I mean it is 14.4 watts, but what you remember is the capacitor's discharging. So it's only like we're saying on average it's 14.4 watts. But at the very beginning the light is brightest, so it has the most power output. And at the very end the light is dimmest, so it have the least power output. So this is why we're saying in the question approximately, you know, because it's not a constant. We're just saying it's like roughly 14.4 watts per joules per second. Okay, question, yes.
Time to discharge a capacitor is always 5.
This is the convention. It's not really a rule. It's just a convention. In some situations it might be appropriate to use a different number, but for the IFY course we take it that the capacitor is fully discharged after 5 time constant. Although technically speaking there might be a tiny charge left after it. The problem is the exponential formula doesn't actually cross the x-axis. So technically and mathematically it never discharges, but at some point it becomes so small it's effectively discharged, which we consider that point to be 5 time constants.
And is this different for different materials of capacitors?
No, we always say 5 time constant. What is only different is the accuracy in the measuring equipment. So if the measuring equipment is able to measure in, say, nanovolts, then 5 time constants would be inappropriate because you could still pick up the small charge left in the capacitor. So that's why I'm saying for IFY high school level, we treat it as 5 time constants. Okay, continuing. Yeah. So, not very difficult. All these questions are short enough. I will give you a few minutes to try these now, and then what is the next lesson? Let's see.
If we wanted to find 5 cells, do we have the thingy on our calculator?
What thingy?
The value of cells.
No. Oh, I'm sorry. When you said I thought when you were asking me the 5 tau, if the 5 is different for the material. No, the 5 is the same, but you were asking me is the tau different for the materials. Yes, the tau is different because the formula for tau is RC,
Okay, I thought it was.
a material constant.
Yeah, a
No,
constant, yeah.
tau is equal to RC, which is obviously different for
Yeah,
each
yeah.
material. Okay, can you try these questions now, please?